All right, gotten a couple of questions about static and non-static. And if you get the error, non-static cannot be called from a static context, stuff like that, what does it mean? So essentially there's two different kinds of variables, just like there's two different kinds of classes, methods. They're broken down into class variables and instance variables. Instance variables are the ones that change on an item by item basis. You know, somebody's height, somebody's weight, that kind of stuff. If we have a class named people. Whereas class variables are things that apply to the class, not to the instance. And I always have just a little bit of difficulty coming up with the idea of class variables. Pretty much everything that we think of is an instance variable, the attributes that each object has. So this is the stuff that varies on an object by object basis. And then you could have something that applies to your people class as a whole, like the number of people that have been created by your system. Each object, Fred would not have a different number of people than Joe, although Fred would have a different height and weight than Joe. So the number of people is an attribute of the class itself, whereas height and width are attributes of the objects created from the class. So class variables are created by the static keyword. Instance variables leave off the static keyword. I'm going to hit a few of their slides that I just ransacked at random. So static rules and variables. Static variables and methods, because there's two kinds of methods as well, instance methods and class methods. Everywhere you see the word static, you can substitute class, like the book calls it. They're the same thing, class and static. Static variables and methods belong to the class in general, not to individual objects. The absence of the keyword static makes it dynamic. Our book's calling it an instance variable. A dynamic method can access all dynamic and static variables and methods in the same class. Now this would be all real good if it used the lingo that our book used. A static method cannot access a dynamic variable, because how would it choose which one? A static method cannot call a dynamic method. So I think my example the last time was that we had some kind of robot class and it had a global switch that shut them all off or all on at the same time. So we had a static Boolean called, running, or they were powered or whatever. And then each robot had its own name. So you had a robot class. This is a class member. This is a class variable. And this is an instance variable, which that slide is regrettably calling a dynamic variable. It's an instance variable. It's non-static. The robots as a whole, we have a master switch which shuts them all off at the same time and all on at the same time. So that is why we made it a static. The static applies to the class as a whole. Is this class active? Do we have robots running around? Well, they're either all on or they're all off in my silly example. So another example might be if you're coming up with a human species, types of humans or whatever, then, you might care about, their weight, their height. What else do we care about? Their age, things like that. Country of origin or where they were born. Things like that. Each human differs in all that, but all humans share the same genus, Homo sapiens. So if you were going to create a human Fred would be the same genus as Marjorie, who would be the same genus as, Sally. They all are of this same one. So we don't need to make that an instance member. This would be static. It's a class member. It applies to the class as a whole. Whereas these are instance members, so they're non-static. Fred has a height, age, weight, and origin. Sally can have different height, age, weight, and origin, but they both have the same genus. All humans share the same genus, or else they're not humans. So our rules of thumb are: static methods can only access other static methods and members, variables, in the same class. Non-static methods can access static members and non-static members. So for example, if our robot class, we have a variable called running which shuts off all the robots at once. So we may want to make a method that shuts them all down. Shut off robots, like that. It's going to do that. Well, we're going to make that static because it's going to apply to the entire class. And so when that is called, we would set running equal to false. Now that's great. We have a static method and it's accessing a static variable, a class method accessing a class variable. That's all well and good. But when we call shut off all robots, should we also print, name has been shut down, and then try to, do the same thing, So we have a robot R2D2 is equal to new robot. We set that name R2D2 equal to R2. And then we have another one, robot C3PO is equal to new robot. C3PO's got a name. Alrighty, so there we go. And now we're going to shut them off. Robot dot shut off robots. That's all well and good. So that would invoke this method. It would set running equal to false. Now all the robots are not working. And can we print name has been shut down? Well, which name would we be shutting down? Are we shutting R2 down or are we shutting 3PO down? This method has no way of distinguishing. So you cannot access non-static members from a static context. So we'd have to comment that out. Cannot access non-static members from a static method. Go back and check. The difference between static and non-static variables in Java. Non-static variables, our instance variables. They're also known as instance variables because whatever memory is allocated whenever the instance is created. You create a new robot, it allocates some new memory. Just hold that data for the robot's name. You create a new human, it allocates new memory to hold that human's age and weight and height and origin. So all of that data is specific to an object. Yeah, you might have two robots with the same name, but they don't necessarily have to be the same name. And non-static variables can be accessed with an object reference. That's poorly worded. But what that means is that when you access the member, you do it with the name of the object, r2d2.name. I goofed this because it should have been r2d2.name is equal to, sorry about that, and then C3PO's name right? So when we access these, we access them with the name of the object, like that. But when we accessed a static method, we accessed it with the name of the class. So access non-static members with the name of the object, with the object reference. Access static class members with the name of the class. Now, honestly, you can usually get away with calling a static member and then prefacing it with the name of a specific object. The compiler, some compilers will flag that as a warning. Others just won't let you do it. Some don't care at all. They're happy to let you do it. But in general, you want to access it by the name of the class, because we're shutting off all the robots. We don't just want to say r2d2.shut off all robots. We're shutting them all down at the same time. So static variables. The memory for the static variables are allocated at the time that the class is loaded. So even before we've created any robots, that switch has been enabled. Even before we create any humans, their genus has been set. So static variables are common for every object. Common for every object means that every human created has the same genus. Every robot created shares a single on-off switch. And the static variables are accessed with the class reference. So when we access the shutoff function, we did it with the class. And if I was following good programming, I would have made that an uppercase, and it would have been blatantly obvious that this was a class name, right, because it was uppercased. Whereas these are object names because they're lowercased. Same for human. I should have capitalized human. You know, and the genus is a string, whereas, you know, the height and the weight and all that stuff, or whatever they are. So this would be static, and these would not be. I'm not going to go to, you know, age and origin and weight and height, whatever. You know, are they floats, are they doubles, who cares? You get the idea. So to sum up, well, let's go look at the third slide that I had randomly nabbed. That one. That's probably about enough. Should assign a video on. So static variables and methods belong to the class, not to any individual object. So all the individual objects share those variables, and even if you don't have any individual objects, then you can still get a hold of them. So one thing that we tend to do is, like, if we have a mouse class, every time you create a mouse with its constructor, we increment the number of mice that have been created. Static int num created. So the first time we call the constructor, num created is equal to 0. The second time we call the constructor, num created becomes 1. Well, that's not right. When the class is loaded, this variable is initialized to 0. But then whenever we actually create a mouse, then that thing is 1. So if it looked like this, you know, if we printed, let's make this uppercase. And then we created a mouse, and then we printed it out again, and we created another mouse, and then we printed it out a third time. So this variable is created, since it's a static member, it's created as soon as the mouse class is loaded into memory. So it's available to us here, but it's 0. Nothing has changed it. And we access it with the name of the class. Then we create a mouse. Well, the creation of the mouse class calls the constructor that adds 1 to the number of mice created, and so when we print it out again, it would print out 1. Then when we created a second mouse, it would also call that constructor. And when we printed out mouse.num created, it would now be 2, and so on. I don't come up with a lot of uses for static variables, and so we wind up spending a lot of time talking about them, and I can't come up with a great examples of them. So one problem is that when we make our program, main is always static. Like that, right? Which means that if we stick other methods in our primary class, in our main class, they also have to be declared static for main to be able to access them. So you come up with a get data method that's supposed to return an int. That's all well and good, but it has to be declared static, or else main is not going to be able to get to it, because static methods can only call other static methods. And so you wind up, if you continue to expand upon your main class, putting everything as static. And then you start making your own classes, and your urge then is to make everything static because you did it in your main class. No, in your own classes, probably nothing is going to be static, unless you can think of a good reason. One thing you will see people do is something like this. Program P is equal to new program, and then they'll run some kind of code in it. P.main, something like that. This would actually create an object so that you could have non-static members in the class that were then able to run. Not gonna fuss with talking about that any more than just to mention that. Sometimes people have a class which creates a copy of itself in order to actually start using it, and then sure, you could make all your data non-static. Another thing I wanted to mention is that you can put classes in weird places. Typically, each class should go in its own file. But you can do this. File name program. Class, helper class. And then put something in there, and then you have your class program with your main class. Oh, come on. Like that. That's legal. You can only have one public class per file, although you were somehow managing to have both, and it had weird side effects. So each class should go in its own file. More specifically, you can only have one public class per file. You can do this, put multiple classes in the same file, but only one can be public. Okay, that's well and good. Here's something else you can do, and this is getting a little bit odder. You have class 1, and inside class 1 you decide that you're going to declare another class, class 2. And then so down here in public static void main, you could create something from class 2. 2 object is equal to new 2, like that. I'm not sure if we would have to declare this class as static or not to get that to work. I'm going to fire up NetBeans and try it. And the third thing you can do is just define the class straight inside of the method. And that's getting a little bit more and more silly in my opinion. Because why would you only want that class definition to be inside the function which is using the class? That means that no other function would be able to use it. Well, you can do that if you want. Kind of off in the you can do this, not I can explain why you would want to do this territory. Okay, so I have a class here called Java Application 2. I can make a helper class helper, public void say hi. That's all it's going to do is print hi. I can also define a class right here inside Java Application. Class helper 2. Public void say hi. And it's going to do something else. System.out.println. Let's make it even called something different so it's obvious. Println hello. Alright, so notice that this class is outside of our main class, which is Java Application 2. This class is defined within. So down here in main, I could create one of each object. Helper 1, helper h1 is equal to new helper. Did I make everything caps like I should have? Don't recall. Nope. Getting sloppy. And then helper 2, h2 is equal to new helper. And that's giving me an error. Incompatible types. Helper cannot be converted to helper 2. Oh, well, that's obvious. I called the wrong constructor. Still an error. Non-static. This cannot be referenced from a static context. And why is that? It's because this class is not defined as static. And what did we say? Once you're in a static method, the only thing that it can access are other static methods and members and classes. So if I wanted to, I could declare this word as, call that static, and that gets that error to go away. Now we have written a class right here that is only accessible, only usable from within this class, right here. Kind of weird, but that's true. We could define a third class if we wanted to right here. Class helper 3. You know, whatever. I'm not going to even put any data in it. And then so helper 3 h3 is equal to new helper 3. Like that, right? That's okay. It'll do it. But we've created a class that's absolutely only available within the main function. Even other functions inside the same class would not be able to create or access, you know, this class. So that's pretty weird. This was not that uncommon. You're going to make a class that's only accessible inside this class. Well, at least every method inside that class would then be able to use it. But if you wanted to, you know, create other classes and other files and have them use the same class, you know, for sharing data or whatever, they would not be able to do so. So in general, you know, I'm not going to penalize you if you don't put every class in its own file. That's the recommendation. I'm not going to count off for it. But don't be embedding classes inside of classes or embedding classes inside of methods unless you have a darn good reason for doing so. I can't give you those darn good reasons, so I just recommend not doing it. Okay, so we were talking about, I don't know if you all actually wanted to type this in or if you just wanted to see the example. It's pretty convoluted stuff, but is anybody typing this in and wish they had more time to finish typing it in? Probably not. Okay. I'm going to make a new one. Okay, so we were talking about array lists. That is one form of abstract data type, but there are others. Specifically, there are stacks and there are queues. Stack is like a stack of dishes, a stack of anything. I push something onto the stack. I push something else onto the stack. I push something else onto the stack. I pop something off the stack. It comes off the top. I push something else onto the stack. I push something else onto the stack. Then I pop that one off the stack. And I pop that one off the stack. And I pop that one off the stack. You see, the stack is growing and shrinking. Notice that that means that all access to it is done on one end, right? If I was going to line these up in a row, you know, I put that there. And then when I wanted to insert something again, I put it, you know, on top. But in this case, I'm saying top is, you know, your left. And then I'd put something else there. And then when I wanted to remove something, I'd take it off the same side. And I'd take it off the same side. And I'd be left with the original thing. And eventually I could take that off. So that's a stack. A queue is when you insert things on one end, but then they're removed from the other. You know, the English call people standing in line to get into a movie. They saw it standing on queue or in queue rather than saying standing in line like we do. Why is it a queue? Because you get into it at the back and the people get into the movie theater from the front. So if these items were in a queue, all right, he's in line, he's in line, he's in line, okay, flip, blip, he's in line, nope, I'm going to take him, he's first, and now I've got all of our objects. So whenever I teach about queues and stacks, I usually get asked, why do you use a stack? Why would that even be invented? And that's more for computer scientists to use in their programming than in real world applications, right? You know, if you implemented the way to get into a theater as a stack, and so the first person in to get into the stack was the last person to get into the movie theater, they would be really annoyed. Let's make some notes. Stacks, inserts, and removes are done on the same end. And the technical term for that are push and pop. Queue, inserts and removes are done on opposite ends. Inserts happen on one end. Removes happen on another. And different versions of it call them different things. You know, some people call them in queue and DQ. Some just call them add and remove. I don't quite exactly remember which version we're going to see. We'll go and update that. So stacks are more like the undo command. Undoing stuff is done in a stack. So if I type 1, 2, 3, and then I undo something, flip, it took that last thing off. And now it took the other last thing off. And then if I start adding more things, 4, 5, and then I undo those things, the 5 is what's removed first, and then the 4 is removed first. And if I kept undoing, even that 1 would be. That's a stack. That's a stack in action. You wouldn't want the first thing to undo to be the first thing that you did, right? You'd want it to be the last thing that you did. You type in something, you type in something else, you type in something else, you hit undo. You want that last thing to be the one that's undone. So stacks are what is known as LIFO, last in, first out. The very last thing you put on the stack is the topmost thing. It's the first thing that's going to be removed. The last change you made to your document that you undo is going to be the first thing that's undone. Whereas queues are FIFO. First in, first out. There's all sorts of ways to implement stacks and queues. Or when I say lots of ways to implement them, if you start looking at the collections classes, as talked about in the book or as in Java in particular, I mean in this textbook in particular, they'll show you lots and lots and lots of different collections. There are double-ended queues, and let's see, collections in Java. Let's just see if we can get a list of them. The collections framework. So there's the list. The array list is a form of list. There's the stack. And then there's the queue. And then once you see queue, you'll see a whole bunch of them. Linked list is considered a queue. Array deck, which stands for double-ended queue, is a queue. Well, that just happens to be a queue that you can insert into both ends, which kind of strikes me as odd. Priority queue. Okay. So, and then linked list also supports both the list interface and the queue interface. So the linked list is a more flexible one that can support multiple things. So anyways, you wind up seeing a lot of different options when you come and you look at these things. So I'm just going to choose one that I'm pretty sure that's going to work. I want to illustrate the java.util.stack. I don't care what our textbook says to use. Let's see if it says to use that one. I think stack is fine, but queue is not. Okay, so a stack is a last in, first out. Did I say first in, last out? They mean the same thing. Last in, first out. FILO and LIFO would be the same thing. You push things onto it, you pop them off. So let's play with that. All right, now I do actually want to do this stuff. So I'm going to create a stack. Stack of plates. It's going to be a stack of string. I'm going to call it plates is equal to new stack angle braces and then parentheses to invoke the constructor. It doesn't know what a stack is, of course. So I'm going to add an import for java.util.stack. So I'm going to push some plates onto the stack. Plates.push a red plate. Plates.push a white plate. Plates.push a blue plate. Now I'm going to take everything out of the stack. So while plates dot empty is equal to false is one way that I could do it. My favorite way is to just check the size. While plates dot size is greater than 0, let's push something off. Size is a method, by the way. I forgot to put its parentheses. Let's push something off the stack. Plates, except I said push, we're going to pop something off the stack. And then we're going to print it out. System.out.println popped, followed by the plate that we just popped. And it'll keep doing that until the stack is empty. Each time you pop, it removes the element from the data structure. I'm going to put some print statements here just so that I can see what I'm doing. So it's going to wind up being copy and paste business here. I'm going to copy that print statement. And I'm going to add a print statement here that says pushed red. And then I'm going to copy that and make it say pushed white. And then pushed blue. So when he runs, he's going to say pushed red, white, and blue, but then when he pops them off, they're going to come out in the opposite order. So pushed red, pushed white, pushed blue, popped white, popped red. Came out in the opposite order. What if we'd only pulled off 2 of them? Well, then that red one would have still been there. So I'm going to push a couple of things onto it and then remove them and then push something else. So plates dot push green 1. We're going to have several different colors of green. And then I'm going to push in green 2 and green 3. And then I'm going to pop 2 plates off the stack. I'm not going to even print them off. Plate stop pop. Plate stop pop. And then I'm going to push one more on. Plate stop push. Green 4. Let's use a for each loop to print out the contents of the stack without physically destroying the stack. I guess it's not physically, right? But when you pop it, you're removing stuff from the stack. Now, using a for each loop kind of violates the idea of a stack because we're actually traversing, the whole thing rather than just the top item. But we have the option available to us, so let's go ahead and do it. So for every string S in the plates, let's print out S. System.out.println stack colon end quote plus S, so that we'll see what's left on that stack. But let's predict. After we've pushed 1, 2, and 3, if we do a pop, what's the first pop going to take off? Is it going to take out green 1 or green 3? It's last in, first out, so which is the last thing we pushed onto it? Come on, guys. Yeah, so we're going to remove green 3. This one's going to remove green 2, leaving only green 1 on the stack. So when we push this one on, now it's going to say green 1 and green 4. And if we popped them back off, it'd say green 4 and then green 1. But the for each loop, I believe, doesn't go in that order. Again, it violates the spirit. Right, okay, so that's what our stack contains. After we pushed green 1, green 2, green 3, we popped 2, and then we pushed one more on. Stacks are used in programming, making languages. Every time you call a method, it creates some data on the stack to hold those variables. And then when you exit from that method, all of that data is lost. So like this, if we have a method 1 that's got, int x, y, and z, and then we have method 2 that's got, int a, comma b, comma c, and it calls method 1, and then we have method 3 which calls both method 1 and then it calls method 2. This would be easier to draw on the board, but nobody would see it who's watching a video at home. So let's say that, let's call this one main instead. So we enter main, and let's say that this creates one more variable too. X, Y, Z, A, B, C, so this is going to be variable foo, whatever. Okay, so we start running main. It allocates a variable called foo. Now we call method 1. We call method 1, it has to create space for 3 more variables. It does something and it returns. These have been created on the stack. When it returns, they go away, right? Because these are local in scope. Nothing can access them outside of it. So they get erased. He comes back here, he's done with method 1. He's going to call method 2. So we call method 2, it hops over here, and what does method 2 do? Method 2 has 3 variables. I hope I was typing X, Y, and Z in the right place. And then it calls method 1. So when we enter method 1, it creates those variables. When it exits method 1, those are erased. And then when it returns out of method 2, those are erased. So you see a stack building and shrinking and growing and shrinking for all your local variables. So you would not be able to write programming languages and compilers without stacks. Hope that made sense. When you allocate data, there's 2 broad places that data can be allocated. You can allocate things on the stack, which is where your local variables go, and on the heap. I'm just going to mention those terms, and then we're going to come back to them at a later point. So we've done a queue, we did a stack. Let's go ahead and do a queue. I'm going to eyeball and see which way that the book wants us to do a queue, if they even give us any hints. Okay, so the queue class is actually an abstract class which cannot be implemented. But a priority queue is. It's, not an abstract class, it's an interface. And you can't create an instance of an interface. So, we're going to use priority queue as our queue type. So let's go back to our stuff and create a priority queue. Priority queue. These aren't plates, these are printer jobs. So I'm going to call them P jobs. But I need to specify what type they are. So priority queue, angle braces, string, P jobs is equal to new priority queue. Of course, we have to add the import for it. Add import for java.util.priorityQueue. I'm going to do a show Java doc on a priority queue. The priority queue has several methods. Let's find out what the methods are. There's one called poll, which retrieves and removes the head of the queue. And then there's one called add, which inserts things into the queue. So where I was typing comments about queues and stuff like that, the act of in-queuing is called add. The act of dequeuing, removing something from the queue, in this particular class is called poll. So add adds to the queue. Poll removes from the queue. So I'm going to go back down now to our printer jobs, and I'm going to add some printer jobs to the queue. So pjobs.add job 1. pjobs.add job 2. pjobs.add job 3. pjob.add job 4. Let's remove a couple of items from the queue. String s is equal to pjobs.poll, and let's print it out. System.out.print pjob poll equals plus s. And I'm just going to copy that there, so that we have two copies of it. So queues are first in, first out. So we added job 1, job 2, job 3, job 4. When we do a poll, when we remove, what's going to be the item that gets yanked from it? First in, first out. So what was the first thing we added? Yeah, we added job 1, so that's going to be what we pull out here. And then the next thing we pull out is going to be job 2. So if we go ahead and add 2 more jobs, pjobs.add job 5, pjob.add job 6. Now let's just do a for each loop that's going to print out the entire queue. And again, that violates the spirit of a queue, as well as violating the spirit of a stack, because the spirit of a queue is that you should only be able to access things on the end of it. and you should only be able to insert things into the end of it. So getting this mysterious ability to walk along the queue and examine each item is a violation of the spirit. But for every, for string S, oops, I already called it S here. Oh, pooey. T. For every string in the printer jobs queue, we're going to print it out. System.out.println pjobs q colon plus a T. And there we go. So we inserted onto the stack jobs 1, 2, and 3, 4, but then when we pulled off the first two items, and then so later on, oh, I have a little problem here where I put spaces on some and not the others. The next two jobs got added to the end of the queue. So it says 3, 4, 5, 6. Whereas when we printed out our plates, they came out in the opposite order. That's the difference between first in, last out, and first in, first out. There are even cooler data structures. Okay, maybe not cooler, but there are ones that I think that are plausibly more useful than that. The equivalent of the dictionary class in Python is what I'm thinking about. So the Java collection framework has two interface hierarchies. They have a collection hierarchy and a map hierarchy. The maps are the equivalent to the dictionaries. Java calls them maps. Python calls them dictionaries. The collection interface has methods that are common to all collections. Add, contains, is empty, size, and remove. All classes that implement the collection interface provide a one-parameter constructor. The collection hierarchy includes a special kind of queue called a priority queue, which always inserts high priority items closer to the head of the queue. So the stack is not considered part of this. But I would have sworn that a stack was one of the collections. I don't really want to talk about maps yet. And the rest is just code examples, is it not? All right, what method do you insert another element into an array list? What were we doing last week whenever we wanted to put something in to an array list? Don't be fooled by the fact that it says insert. We always just called add, and we specified its position if we wanted to insert rather than append. Which Java API class provides the best implementation of a stack? Well, that looks awfully tempting. Honestly, you could use a double-ended queue to implement your own stack, but you could also use an array list to implement your own stack, if you so chose to. And I think that's the last thing I would like to do today, is to go ahead and create our own stack class using an array list. Now this is kind of silly, but let's just roll with me here. So I'm going to go and I'm going to create a new class. I'm just going to put it above my other class in violation of my recommendation that all classes go in their own files. So class, I'm going to call it my queue. And it needs an array list in order to function. So array list of whatever kind of data that we're tracking. My queue is going to be a class full of strings. Array list string data, good enough, is equal to new array list. And we better add. So what are we going to do? We're going to add two methods, a push and a pop. And then we're going to do another one called size. And by the way, I didn't mention it, but there's also the command called peek. The peek method does the same thing as pop or poll, except it doesn't delete it, right? It's just looking at the plate without yanking it off. Or it's going and looking at the first person in the queue without letting them out of the line. So there's peek as well. I didn't talk about it though, but you get the idea just from what I said, I hope. Okay, so we're going to need two methods. Public void push, that takes a string. And we're going to need public string pop, that returns a string. And then lastly, we need to be able to get the size. Public int size. And I should not have been making these capital letters. I don't know why I did. I'm going to change pop to lowercase p, push to lowercase p.
Why does that matter? Oh, I see.
Naming conventions, that's all. I want to be a good programmer, so I'm following my naming conventions. Pardon me?
That's not why the red line is showing up.
It's failing to do that correctly because I haven't actually got it returning anything yet. Well, it's not supposed to. Identifier expected. Oh, because I haven't given a parameter a name. Okay, there. So when we push something, we want to insert it. Well, since it's a stack, we want to do all of our insertions and our deletions from the same end. In my way of thinking, the easiest way to do that would be to always use the front of it, to add things to the beginning of the stack and to remove them from the beginning of the stack, rather than to always append them and then try to remove them. Because the length of it, will vary, but the first item is always 0. So when we push onto it, I'm going to take my data and I'm going to add that element into position 0. Insert into beginning, into start. I've got it in the wrong order. Index number comes first. Now when we pop string s, we need to get that piece of data out. S is equal to data.get, and then we need to return s. But I did not specify which element to get, and like I said, we're doing everything on the same end. Get from the start. But we also need to remove that item now. We've just gotten it out, we need to remove it. That's what popping means. So data.remove element 0. And then size just needs to return data.size. So it's pretty easy. So now we could use this stack just like we use the other one, even has the same method names. But we could customize its behavior. One thing about the collections classes, the stack that we get from Java, is that if you call pop but the stack is empty, it generates an exception, blows up. We could make this thing return a null if the stack was empty rather than blow up, if that was our goal. So we could customize this behavior. Mostly I did this so you'd get the idea that if you're doing, why did I call this my queue and then I'm treating it like a stack? Excuse me, but call it my stack. But changing it to my queue would be pretty easy, right? We just wouldn't add to the beginning of the list. We would append to the end of the list. Otherwise, everything would be exactly the same. We could copy and paste this, change its name from my stack to my queue, and we would just, when we did .add, we wouldn't specify that we wanted to insert it at the beginning of the list. Instead, we add it to the end. But we might change its names as well because people don't talk about pushing and popping into queues. I guess let's prove that this works. So up here at the top, my stack ms is equal to new my stack. Now notice that our class is not very flexible. It doesn't give you the ability to say what you want a stack of, right? It doesn't give you stacks of ints and strings. These classes are just like array lists. You can only use reference types. You can't use primitive data types like int and float and double. You have to use the wrapper classes if you want that kind of stuff. All right, so ms.add. Let's add, except it's not called add, it's a stack, so it's called push. ms.push Abe, ms.push Bob, ms.push Carol, and let's just pop them off. So I'm going to put 3 print statements. System dot out dot print line, popping ms dot pop. And just to show you that it's going to blow up, I'm going to pop 3 times, 4 times, because we have 3 pieces of data in it. The 4th pop's going to blow up. All right. Notice that they came out in the opposite order, which is what we expect stacks to do. First in, last out. Last in, first out. But it blew up. That's true of all of the collections that Java gives us. How can you do that? You could call .size before you accessed it. Or you could add exception handling in order to get it to work. For stacks in this class, we use java.util.stack. For queues, we use java.util.priorityQueue. So for stacks, what are our 2 commands? Push and pop. For queues, what were our 2 commands? How do we put data in it? Add, and how do we get them out? Pull. Yep, and for array lists, we have add, comma, get, and remove. Like that. They all support .size. And dot is empty, which to me is superfluous because you just call .size is equal to 0, but whatever. Stacks and queues support .peek, which returns the top element, the first element. What happens if the stack is empty and you still call .peek? Does it go kablooey? Let's find out. Returns null if the queue is empty. That's nice. At least it doesn't generate an exception. Otherwise, if you call pop or pull on an empty structure, generates an exception, which halts your program. Apparently there was an 8 that I skipped. And the array list and the 2D map array. Guess I'll open that one up as well. Alright, so after our lectures, if you've been watching the videos that we did, or, that I assigned, and the in-class lectures, we should be well ready to do this one, the array list and the 2D map. But of course I'm going to give us some time. We have spring break coming up and all that. So let's see what the instructions are. So the objective of the lesson, of course, is to understand two-dimensional arrays and to use the java.util.array class. So your program must, at the end of processing, display a 40 by 40 array of numbers in a grid. Randomly selected positions in the array will contain non-zero values between 1 and 9. The rest of it will be all zeros. The values will initially be stored in an array list before you put them in the two-dimensional array. So our output should look something like this, except obviously that's not 40 by 40, right? But it'll be an empty array, and then we will generate pairs of coordinates that give us non-zero values. And then if you want to, you could replace all the zeros with dots and you get some nicer looking output. So here's how I want you to implement it. Make a point class. The point class should have an x and a y and a z. The x being an x position, or the row. The y being the y, or the column, and the z being the value. Then create a two-dimensional array of ints, and call that map. Create 40 point objects that are randomly generated. X should be between 0 and 39, y should be 0 and 39, and z, the actual value of it, should be between 1 and 9. And so use the array list to store those point objects. Then move each one of those points onto the array, or iterate through the array list, getting all those points. And so like if you have a point that's got the values 3, 7, 2, well, at position 3, 7 in your two-dimensional array, you're going to put a 2. And then you display the array. So I give you a random number generator if you want. And then here's our sample output. Although this one's only adding 5 points. So it created a map. Excuse me, it created 5 points. 7, 9 has a value of 3. 9 and 14 should have a value of 2. Position 2, 7 will have a value of 8. Position 6, 10 will have a value of 4. And position 7, 5 will have a value of 2. So these are all added to the array list, and then using a for each loop, you run through the array list, pulling those things out. So at 7, 9, we put a 3. And then at 9, 14, we put a 2. And then at 2, 7, we put an 8. And then at 6, 10, we're going to put a 4. So 6, 10, 4. And then 7, 5 is going to be a 2. And it's okay if they overlap each, If you generate 2 points with identical coordinates, that's going to happen when you generate a lot of points. And if you take my suggestion of replacing the zeros with dots as you print them out, it's going to look like that. Now there is also a file called help. You get stuck or you just want to read it, you can. Gives you a lot of hints about how to do it. Too much help, in my opinion. I ought to remove this, but I won't. Okay, so that's that assignment. So that's during spring break, is it not? So we're going to set this one due the Wednesday after spring break, which is really a lot of time. Don't wait until the last minute to get these done. because by then the lectures will have burned out of your brain.
That's one thing I've noticed. Like a week later, I almost always forget everything.
Right. Well, that's why the videos are there. You can always go and refresh. And then we have one called 2D arrays, which I'm going to make do at the same time. No, that's the one we just looked at. Okay, well, it certainly is going to be due at the... That's a daily assignment. I'm getting myself confused. Okay, so then there's the math stack. Write a program that uses a stack. The user will get to type numbers. Or you can make it read from a file, but we haven't done any file reading in this class, so you may as well let them type it in. Use the java.util.stack class, not our own homemade stack class. So, the rules. If they type in 0, well, let's say that if the number is even, it gets pushed onto the stack. Every time they type in an even number, it gets pushed onto the stack. If they type an odd number, it pops the last value off the stack, multiplies it by what they just typed, and prints the answer. If they type in a 0, it pops all the values off, summing them up. And then if they type in a -1, it exits the program. So, let's say that this is our sample input. Here's our output. Even numbers are pushed onto the stack. Odd numbers are multiplied by the value popped from the stack. 0 will pop all the values and display their sum, and -1 will exit the program. Please enter a whole number. So they typed in 2, so that pushes it onto the stack. They type in a 4, so now there's 2 items on the stack, a 2 and a 4. They type in a 6, now we have 3 items on the stack, a 2, 4, and a 6. So then when they type in 0, it pops everything off the stack, adding them together, which is the 6 and the 4 and the 2, which gives us the sum. Please enter another whole number. Well, it was an even number, so it gets pushed on the stack. Type in another number, it's a whole number, it gets pushed on the stack. Now they finally have typed in an odd number. So it pops the last number off the stack and multiplies the 2 together. 12 times 13 is 156. Now they typed in a number, it's another odd number, so it's going to pop a value off the stack. Well, we already took the 12 off the stack, so 10. 5 times 10 is 50. Please enter a whole number, -1, the program is done. Your output doesn't have to be exactly like that, but you know, the sums and the products ought to be the same. Required error handling. Don't allow the program to crash if they try to pop something off the stack, but the stack is empty. So always check the size of the stack before you pop it off and do something with it. All right, does that one make sense? In my mind, that one's actually a lot easier to implement than the two-dimensional map. But on the other hand, with the help file that I give you on the two-dimensional map, then that one's not too difficult as well. But I'd like for y'all to wrestle with it before looking at it. Read the help file if you want, but then don't just follow. Don't, you know, copy all the code and paste it. Cook up your own program. All right, that makes sense, guys? All righty. So, it is fairly, at some point, we're going to have an exam. I don't want to make the exam due until those homework assignments are due. So let's set an exam for the 29th. It'll be open the week of the 29th from 29 to 5. But if you want to come in and sit in on my C++ class that meets after y'all do and take your exam there rather than pay for it or go to the Learning Resource Center, then you can do that. Make sense? All right, because this class is pretty small. There's room. Okay, let's make a Dropbox and upload your file and we'll be done.